Alright, so this is part 2 where we're just going to focus on secant and cosecant. So we're going to talk about what the functions look like themselves, the secant and cosecant graphs, and then some of the facts about them, and then we'll look at a summary of all 6 altogether. So the way that we usually look at secant and cosecant have all of these radicals in them. But something that you'll start kind of noticing here, I mean, first off, we have, again, some undefined points, so we're going to have some asymptotes. But just looking at secant, we notice in this little section here, we go from -2, we go up to -1, and then we decrease back down to -2. So we're going to have this curve that increases and decreases. And you can't see it, but we have, you might not notice, but through these 3 numbers, we're also increasing up to 2. And we have some asymptotes in cosecant as well. So here in cosecant, we start at 2, we hit a low point at 1, and then go back up to 2. So let's take a look at what that looks like. To graph it, we're going to graph the reciprocal. So if we're looking at secant, that's cosine, and if we're looking at cosecant, that's sine. Then you're going to plot in your asymptotes, and that will be anywhere there's an x-intercept in the reciprocal. And then we're going to get these u parts of the graph, the 2 down to 1, back up to 2 parts. And they're going to fit in between the asymptotes. So for secant, we're going to start off with cosine. And let's call this 1 right now. So start and end at the same height. Go down here. 0's here. I'm going to leave it dotted because this isn't actually the main part of the graph. And then anywhere it crosses the x-axis, I get an asymptote. And then the secant part of it, we get these U-shaped parts that fit in between. And actually, we could continue back into the negatives. And we could see we're going to get another U right there. So for cosecant, we're going to start off by graphing sine. Anywhere there's an x-intercept, I get an asymptote. And then in between the asymptotes, just touching the reciprocal graph, we draw in these U-shapes. So here's some nicer versions. Here's the nicer version of secant. The secant graph is all of the green parts, and the blue part is just the cosine that helps us graph it. Cosecant, just these purple parts up here. The red graph is the sine that helps us graph it. Let's go over some of the facts that we have about secant and cosecant. So we do have some restrictions on our domain and range. For secant, that's going to relate to cosine. And so anywhere there's a 0 in cosine, we're going to have an asymptote in secant. Oops, let me get a pen up. So we're looking here at odd multiples of pi over 2, which should sound familiar. In the cosecant, just a reminder, we're going to get our asymptotes at the multiples of pi. That's where the zeros are in sine. So the domain will be anywhere that's not the asymptotes. Since this is written sometimes like k pi over 2, where k is odd. And for this one, we can just write k pi, because it's just any multiple of pi. The range is the same for both of them, so I'm going to write it in the middle here. We go from -infinity up to -1. But we're going to jump over that section in the middle where sine and cosine would be, pick up at the top of those graphs, and go back up to infinity. So here's all 6 functions with their domains, range, asymptotes, zeros, and whether or not they're even or odd, which gives us some information about their symmetries. The only thing I want to point out here, maybe you'll just pause and copy down the rest. I said that cotangent didn't have a symmetry, and I was mistaken. It does have symmetry. It's an odd graph, so it's symmetrical about the origin.